I'm Dr. T and welcome to my office. Today I'd like to talk about working with chemicals and doing kind of a risk assessment. Before you start working with chemicals, you always want to do a risk assessment. And in some cases, I mean actually like go through a formalized process, but in others, you know, just kind of check off in your head, okay, what do I know about these chemicals kind of thing. Now, if I'm encountering chemicals that I've not used before, I've got a couple of things I'm going to go for. For starters, I'm going to think about kind of 4 vectors or 4 issues I could have with the chemical. The first one is this chemical capable of doing a particularly energetic reaction? So is this something like gasoline where it could catch fire and produce a lot of heat and burn me if I'm not careful? Is this something like black powder where it could actually explode? Or nitroglycerin, which is, you know, not in my lab, thank you very much. And so I'm looking at those. Now, obviously, it depends on how much I'm working with. If I'm working with tiny amounts, then it can only go boom so much. But if I'm working with larger amounts, then yeah, this becomes a very serious threat. It takes a lot of PPE to protect yourself from a roaring inferno. So of course, now I'm thinking about this like, okay, do I have the facilities to work with this amount? Because, you know, quantity matters. It matters a lot. This amount of this chemical and protect me if things go wrong or make sure things just do not go wrong, preferably both. And then I'm going to be deciding, okay, do I actually want to work with this dumb stuff? Now, the next thing I'm going to be looking at is how toxic is this? And by toxic, really what I'm getting at is how much is this capable of interfering with biochemical pathways? I'm not talking just gross tissue damage. That's the next thing. But, you know, is it something like cyanide where it can bind to hemoglobin and prevent that from functioning? Is this a heavy metal which is going to interfere with neurons, etc.? And so when I'm dealing with toxic substances, one, presumably I'm going to have PPE, so, you know, okay, I'm going to make sure I use my PPE. How toxic am I dealing with? For all toxic substances, really I like to think of them in kind of 4 brackets, and it's not the different substance, it's how much you have. The dose makes the poison. There's no such thing as safe. So, you know, you can die of water poisoning. It takes gallons of water. You have to drink gallons of water in a short period of time, but you can mess up your electrolytes to the point where you die. However, other things like the aforementioned cyanide, it takes milligrams. So it is not much. So at very low levels, and remember that word very low is relative to what that chemical is and your physiology. At very low levels, it will not have an impact on you. It's just too small. At low levels, it will have an impact. Depends on what it is, depends on what that impact is. People consume chemicals for their physiological impact on a daily basis. Caffeine, ethanol, these are both poisons, essentially. Caffeine's there to keep the bugs out. Nicotine, don't do nicotine, but, you know, all your pharmaceuticals, you're all hitting that kind of low dose range where it's having a physiological impact on you. And that's the whole point of you consuming it. Otherwise, why would you do this? Now, at a certain point, you can get higher up, and that physiological impact is going to start causing damage, and that damage may very well be permanent. So at kind of a moderate level, you're dealing with an exposure that's going to cause permanent physical damage. Obviously, you don't want to get to that point. And then, of course, at a high exposure, it'll kill you. And once again, everything will get to that point. It takes gallons of water to get to that high physical exposure, but you can get there. I don't recommend it. Highly don't recommend it. So, okay, what are these levels for me? Or, you know, what are some ballparks of these? And can my protective equipment reasonably keep me well into the very low or just zero exposure? Ideally 0, but, you know, 0 is a very low number. The history guy has a great discussion of a certain cranberry incident in the 1950s when, you know, we're trying to hit 0 and you couldn't hit 0. So I'll let you watch him. He's got a good one. So can my PPE do this? And of course that means, you know, how much am I working with? If I've got something that, a kilogram will kill me and I'm working with 50 milligrams, there isn't even enough in play, let alone, interacting with it. As well as, honestly, things like skin, etc., are great protective. So, I'm probably going to want to wear gloves if this thing is even remotely noteworthy. Now, a couple other quick points with this. For starters, acute exposure is always not as bad, but sometimes almost as bad as chronic exposure. So if I encounter some chemical once and then get it away from me, that's not going to be as bad as if I encounter that chemical over and over and over and over again. But there are some caveats. Certain things like heavy metals I have to worry about because my body isn't capable of removing them. Humans don't have mechanisms to get rid of certain heavy metals. Therefore, an acute exposure is sort of also a chronic exposure. And so all of those threat levels, that very low, low, medium, and high, are lower whenever you're dealing with a chronic exposure. This is actually to the point where for a lot of the heavy metals, things like lead, etc., where we don't know where that low and very low is. They're low, especially for developing humans like children. So in those cases, we're really shooting for pretty close to zero because we don't know where low is. It is low. So yeah, that's what I'm looking at. This is also where chemical sanitation or chemical hygiene becomes really important. Because in that case, what you're trying to do is keep the chemical on the bench in the beaker and not go spreading it everywhere. This is going to allow your personal protective equipment, PPE, to work much better because, if it's in the beaker, you got the gloves and great. You're not going to be bumping against it with your backside, getting it on the doorknob somehow, then touching it with your hand, etc. You're controlling where this is going. And this is also making sure that any exposure you have, hopefully, once again, your PPE is working and there is no exposure. That's the goal of doing this and doing this safely, that there is no, repeated chronic exposure by getting it all over the place. This is also why you'll find labs are negatively pressured, so that any chemicals that get in the air will be sucked out a chimney and not out into the hallways. Additionally, this is why, ideally when you're wearing a lab coat, that stays in the lab. And it gets on you, well, the lab is this contaminated place. This is where the chemicals are. When you leave the lab, you leave the chemicals, and you don't have this chronic exposure to whatever chemicals are exposing, whatever you're encountering. So yeah, chemical hygiene, absolutely critical thing to keep in mind because that's going to be limiting that chronic exposure. Okay, the third category I start looking at is tissue damage. Is this capable of giving me a chemical burn? So obviously I'm thinking things like acids, bases, oxidizing agents. So of course in a home setting that might be something like bleach, but of course there's a lot of oxidizing agents out there, most of your nitrate salts. Things that if it gets on me, it will cause a chemical burn. Now, of the three things listed, if I'm going to have to get hurt by a chemical burn on a relatively tough part of me that doesn't get a lot of traction is going to be kind of my preferred. Obviously, chemical burn on the eye, that could be catastrophic. You could lose the eye. Same goes for other places. Let's just say there's a reason you wash your hands before going to the bathroom. This is why the basic PPE always has goggles, and that is to avoid any chemical burns on your eyes. Now, I'm also worried how much am I working with. So if I've got, say, some concentrated hydrochloric acid, that can cause some pretty severe chemical burns, but if I'm only working with a small amount, okay, I'm wearing gloves. I'm not an idiot. But my kind of threat level is not nearly as much. If I'm working with a literal tanker load of this stuff, this is a problem. This is something that I need to be uber concerned with. I'm going through the formal risk assessment process. So once again, I'm looking at scale, how much of this material is there that can cause harm, and how extreme this is. This is also where I should point out that not only does amount matter, but concentration. So if I'm looking at, say, hydrochloric acid, concentrated hydrochloric acid, 12 molar, yeah, this can cause a lot of damage very quickly, but chemical reactions speed up with concentration. So if I'm getting that down to 1 molar, that's going to do a much slower chemical reaction. If I get that on me at 1 molar, I walk to the sink, briskly and deliberately, but not run, I walk to the sink and I wash that off. If it's 0.1 molar, I wipe it off with a paper towel and go rinse it off because it might cause some drying. It's not going to cause a lot of damage. Concentration matters a lot. So when I'm working, I'm going to want to be thinking, okay, can I get my volumes down whenever possible? Can I get my concentrations down? For my boring acids, hydrochloric, really most of them, if I can get them under about half molar, that's not too bad. That usually gives me a nice safety border. Vinegar is 0.8 molar acetic acid, so even for a strong acid, if I can get it down to half molar or a little bit below that, ideally 0.1, just don't get it in the eyes or mucous membranes. And if it does get on, you clean it up. Once again, you're trying for 0, but you're building in safety. If things go wrong, well, I've got less of an issue. Now, the last one's a catch-all. Does this thing do weird stuff? Is it like methylene chloride where it goes through my gloves? My gloves won't stop it if I use my normal gloves. Is this producing a gas where I don't just have to worry about it getting on me, I have to worry about it, inhaling, in which case I need to use a hood. Does it have some weird property? Is it radioactive, etc.? So all of those I want to be thinking about and just kind of running through. Now, you can look at a safety data sheet, and you really should. This is going to give you a rundown of all the key features, but what you will find is those are a bit of a pain to read unless you read them a lot. So typically speaking, I like to go look up the chemicals first and go for some kind of plain English. This is also more likely to give me any weird pairings that you don't want to deal with. For instance, if you're working with concentrated hydrogen peroxide, that stuff's a lot more dangerous than the stuff in your bathroom cabinet. That can cause some pretty serious burns because, once again, concentration matters. And also, you don't ever get it around the acetone because the two of them can mix and form an explosive. When I'm looking at this, I'm looking at, are there any weird quirks to this? Anything I need to worry about? The key thing on chemical safety is really, is my PPE going to handle something going wrong with what I'm working with? This means the severity of what could go wrong and how much of it do I have? Can I deal with a situation, or can I use the chemicals in a lesser form? Can I go down in size? That's going to make me inherently safer. Can I pick safer alternatives, if at all possible? But above all, I have thought through, I know what I'm working with, and I know what it could do funky and other problems. And thus, I've got a good start before I've ever walked in the lab. I know what I'm going to be dealing with. So with that said, have a wonderful and safe time in the lab.